AP Chemistry, Molecular Geometry, sigma and pi bonds. Specifically today what we're going to talk about are sigma bonds, pi bonds, general trends with multiple bonds, example using ethene, and an example using ethyne. Molecular geometry and multiple bonds. Covalent bonds can be classified into two types: sigma bonds, which is represented by a sigma symbol, and a pi bond, which is represented by a pi symbol. What are sigma bonds? Sigma bonds are single bonds that include the following situations: an overlap of two s orbitals. So we remember that an s orbital is a sphere, so basically just two s orbitals overlapping each other. An overlap of two p orbitals, and we remember that a p orbital is basically like a dumbbell. So there's one p orbital, and here's another p orbital. So something like a situation of maybe Cl2, where each Cl has 7 valence electrons. So if they overlap, they complete their octet. An overlap of an s and a p orbital, or an overlap of a p and an sp hybrid orbital. And we've seen this before with the situation of BeF2. All of these situations involve electrons along the internuclear axis, or the line joining the two nuclei. And we'll point out in future diagrams what we mean by internuclear axis. What are pi bonds? Pi bonds are a bond that results from the overlap between two p orbitals oriented perpendicularly to the internuclear axis. A covalent bond in which the overlap region lies above and below the internuclear axis are generally weaker than sigma bonds. So let's look at a couple of diagrams. Here we have a representation of a double bond. So this line right here represents my internuclear axis, and that line represents a sigma bond. What you're seeing here is one pi bond, where we have a p orbital right here, and we have a p orbital right here, and the connection occurs above and below that sigma bond that's in between. This interaction above and below represents one pi bond, not a triple bond. I know it looks like a triple bond, but really it's one pi bond because it's involving two p orbitals. So this is the equivalent of a double bond. So that double bond includes one sigma and one pi. So if this represents a double bond, what represents a triple bond? A triple bond is represented here. So what are we looking at? Our sigma bond is going to basically occur between these pink lobes. So this is an sp orbital. So this would represent my sigma bond. My pi bonds would occur above and below the sigma bond. So one pi bond would involve these blue dumbbells that we see right here. So that would be one pi bond. Here's one pi bond right here. And the other pi bond would involve these green p orbitals that we see here. So we see a green p orbital there, one here. So it's almost in the very back and in the front right here. This represents a triple bond. And if you blend them all together, you get this representation over here. And this would represent a carbon-to-carbon triple bond. General trends with multiple bonds. Single bonds are sigma. A double bond will consist of one sigma bond and one pi bond. A triple bond consists of one sigma and two pi bonds. And really, when it comes down to it, this is absolutely what you need to know. Sigma is single. Double bonds are a sigma and a pi. Triple bonds, one sigma, two pi bonds. Let's look at an example of ethene, which is C₂H4. Each carbon needs to form sigma bonds, or single bonds, between the two hydrogen atoms and the other carbon atom. These three bonds need to be hybridized, sp2 hybrid orbitals. That will leave one electron in the p orbital unfilled on either carbon atom. The two p orbitals can align themselves to form a pi bond. So in this model, we see a single bond here, a single bond here, single, single, single. And if we look at these carbon atoms, they're making 3 bonds. So 3 bonds means sp2 hybridization. But again, they told us that this is going to leave 1 electron in a p orbital here, unfilled, and 1 electron in a p orbital here, unfilled. And that's what we see in the neighboring model, where now we have a force of attraction above that internuclear axis and a force of attraction below, and that would be a representation of the pi bond. So again, this is my pi bond up here, this whole thing, and this is my sigma, so this would represent a double bond. Now let's look at Ethyne, also known as acetylene, which is C₂H2. Carbon needs to form sigma bonds, or single bonds, between the one hydrogen atom and the other carbon atom. These 2 bonds need to be hybridized, sp hybrid orbitals. This will leave 2 electrons in the p orbital unfilled on either carbon. These 4 p orbitals can align themselves, forming 2 pi bonds. So again, we're going to have a sigma here, and a sigma here. And that linear configuration gives me sp hybridization. We see this pi bond formed right here and another pi bond formed right here. So this will represent a triple bond. Double bonds only involve p orbitals. D orbitals will not be considered at this time. So what did you learn? We went over sigma bonds, we went over pi bonds, we looked at general trends with multiple bonds, we looked at an example involving ethene, and we looked at an example involving ethyne. Need more help? Feel free to contact me. Have a great day.